Okay, so lesson 1.5, everybody, is on solving quadratic equations. Now, when we talk about solving the quadratic equations, we are looking at the second degree equations. A quadratic equation is in the form of ax squared plus bx plus c equals to 0. Remember, if you have a question while I'm doing the teaching, you can drop it in the chat, guys. I'll be more than happy to answer your questions. Now, why do we call these second degree equations? Because, everyone, the power here, the degree, is 2. So these are second degree equation. So if you have a second degree equation, the max number of solutions, maximum number of solutions you can find for second degree equation is 2, okay, 2. Now, when it comes to the solutions, we also refer them, max number of solutions, we also refer to them as roots. So if they ask you to find the roots, that's the same thing as finding the solutions. If they're asking you to find the zeros, that's the exact same thing, guys, as finding the solution. So if they ask for the roots, the zeros. Also, there's another one called the x-intercepts. Wherever a graph intersects the x-axis, that would represent a root, a zero, or a solution to that equation. All right, moving along. When we talk about the quadratic equations, guys, in order to have a quadratic equation, you must have the quadratic term. So the ax squared is referred to as the quadratic term. That's your quadratic term. Now, in the quadratic term, a cannot equal to 0. If a is equal to 0, you will no longer have a quadratic equation if a is equal to 0. Furthermore, guys, as we proceed through this course, a will be referred to as the leading coefficient. This is, I'm abbreviating coefficient here, guys. This is the number in front of the term with the highest power. So whenever the leading coefficient is mentioned or the a value is mentioned, this means that it is the number in front of the term with the highest power. All right, next, the linear term, guys. The bx term is called the linear term. And we call it the linear term because of that first degree on that variable. Remember, we talked about linear equations last week. So there you go, bx represents the linear term. Additionally, you have the c. The c, always, guys, whenever we're dealing with these type of problems where you find c is always referred to as the constant term. And of course, c doesn't change. And so it remains the same. It remains constant. This is your constant term. Now, as long as you have your ax squared term, you have a quadratic, guys. All you need is that ax squared term. If you don't have an ax squared term, you no longer have a quadratic equation. Now, let me go ahead and highlight some of the methods you can use to solve quadratic equations. Remember, guys, drop your questions in the chat, okay? I'm gonna keep going unless you guys have a question for me. Here's a synopsis of the different methods you can utilize to solve quadratic equations. We've got factoring. Factoring is easy, and factoring solves some of the quadratics. In other words, in order for you to solve a quadratic by factoring, it has to be factorable. If it's not factorable, you can't solve it by factoring. Then we've got the square root property. The square root property is designed for certain types of problems. And yes, right now I am giving you a synopsis of these different methods, and then later on I will go into details, okay? So I'm gonna put some here. We'll solve some of the quadratics. Next, I've got completing the square, guys. Completing the square works really well. The only problem is sometimes you will encounter fractions, and most students prefer not to work with the fractions So they prefer to stay away from completing the square, but completing the square is effective. All right, guys, next. We have everybody's favorite, and that is the quadratic formula. There will be lots of quadratic equations on the test when we meet on the 21st, guys. The 21st is when we're going to meet face to face. It is going to be an A125, okay? Completing the square solves all of them. So that's the quadratic formula, guys. The quadratic formula, everybody's favorite, solves every single quadratic equation. And then the graphing, which is not very reliable, will solve some of your quadratic equations for you. So this is a summary of all the lessons. I am going to go into the first 4 method, I said lesson, method, and then we'll go ahead and take some examples under each one. Now, once again, guys, as I go through this, if you have questions, drop your questions in the chat box for me, please. Okay, factoring, guys, is the first method, factoring. Now, when it comes to factoring, I'm going to give you some steps. Step number 1, you want to set the quadratic equal to 0. Next, you want to go ahead and factor the quadratic equation, factor it. Number 3, once you factor your quadratic, you want to set each factor equal to 0 and solve. Now, the reason we can do this is because of the zero product property, the zero product property. And the zero product property, states this, guys. If A times B is equal to 0, then this means either A will equal to 0 or B will equal to 0. Because when you multiply by 0, you must get 0. So either A or B is 0. So basically your job and using the factoring technique is to find which factor, okay, what value makes the factor equal out to 0. So I am going to do a couple of examples with you guys. As we go through this, make sure you ask questions if you don't understand. You will see some of these questions on the assignments, on the homework, as well as on the quizzes, guys. So here's the first example. I've got x squared minus, x squared equal to 8x minus 15. Now this one, the quadratic is not isolated. So the first step is to isolate your quadratic. So take that 8x, move it over to the left side, so it becomes a negative 8x. Move the negative 15 over to the left side, so it becomes a positive 15. This is the same thing, guys, as adding 15 to both sides or subtracting 8x from both sides, same thing. So essentially, I've isolated the quadratic on the left side. So now it has been isolated. I can move on to step 2 and factor. Remember, in factoring basic trinomials, you want to split up the x squared into x times x. Then you want to find 2 factors of 15 whose sum is negative 8. 2 factors of 15 whose sum is negative 8, guys. And that would be a negative 5 and a negative 3. So now you've got your 2 factors. If you're following through with the steps I just gave you, you would take each factor, x minus 5, set it equal to 0. X minus 3, set it equal to 0, and solve. So you would add 5 to both sides. So you get x equals to 5. And then for the other one, you would get, by adding 3 to both sides, x is equal to 3. So your 2 solutions would be 5 or 3. By the way, when you type in your solutions into my math lab, they do not have to be in sequential order. Now, guys, that was a lot of work there, but listen, all you really have to do is look at these 2 factors and eyeball them to figure out the correct answer. You simply ask this question: what value minus 5 makes this parentheses 0? What number minus 5 makes this parentheses 0? 5 minus 5 is 0, so therefore the answer would be 5. What value makes this parentheses 0? What number minus 3 makes this parentheses 0? 3 minus 3 is 0, so therefore the answer would be 3. It's that easy. Yeah. Okay, so guys, here comes the next example, example number 2. And for example number 2, guys, I've got 3x squared plus 12x is equal to 0. Now this one, the quadratic is already isolated, so we're gonna factor it. Now the first rule of factoring, guys, is to look for, you know, a GCF. Look for a GCF. That's the first thing you always look for whenever you're factoring. Look for that GCF. And this one happens to have a GCF. So if it does have a GCF, factor out the GCF. If you were to take each term here divided by the GCF, guys, that's how we factor out those GCF. That would leave you with x for the first term, and the second term would simplify to 4. So there's the factored form of the quadratic. So you got two factors, 3x, x plus 4. So let's ask the question. Rather than write out the equation, let's ask the question. What number plus 4 makes this parenthesis 0? What number plus 4 makes this parenthesis 0? That one right there will be a -4. So x equals to -4 is the answer for that one. Now, this one right here is a bit ambiguous. And so be careful. You're just asking the question. 3 times what number would make this 0? If you cannot tell what it is, then you want to go ahead and write out the equation. 3x is equal to 0. Divide both sides by 3. And so 0 divided by 3 gives you 0. 3 times 0 is 0. So guys, this one has two solutions. The two solutions are 0, -4. Any questions? By the way, while I'm on here, guys, I want you to know that there is a couple of factoring questions on the test. When we have it on the 21st, it is going to be all multiple choice. Remember that. Okay, guys, I'm going to do one more example and I'm going to move on to the next method. So here comes example number 3, and this one is hard to factor. Now, once you get a hard problem like this and you have to solve it by factoring, that's when you start asking yourself the question, is there a better method to solve this? And yes, there is. Now, the reason why I'm saying this is a bit more challenging is because you will notice the x squared has a coefficient of 3 rather than 1. Notice, guys, I'm moving the +8 over to the left side, so it becomes a negative. When you take a term from one side, you move it over to the other side. The sign, positive, negative, changes, okay? Now, this is a challenging question because the x squared has a leading coefficient of 3 rather than 1. So in order to factor this one, guys, we're going to do the AC method. If you don't remember it, that's okay. There's other ways for you to solve this problem. The AC method, okay? Now, I gave you some of these factoring problems in homework number 1. So make sure you work on homework number 1. It's just a review of factoring, guys. But obviously, I'm teaching you factoring as I go through the class. So on this one right here, everybody, in order to do the AC method, 3 is your A value. You know, it's following the quadratic format. -8 is your C value. So we're going to multiply them together. 3 times -8. That's going to give us a -24. Then you're going to pause and ask this question. What two numbers multiply to give me -24? And then when I add them together, I get a -2. What two numbers multiply to give me 24? And when I add them together, I get a -2. Multiply to 24, add to give you a -2. So this one right here, guys, will be a -6 times 4. So what I'm going to do is to take that -2x and split it up into -6x plus 4x. So there's those two factors. And then I'm going to bring down the 3x squared as well as the -8. So now, guys, I have a 4-term polynomial. And how do you factor a 4-term polynomial? By grouping. You're going to group it. Okay, we're going to factor by grouping. So guys, we are going to group the first 2 terms. That just means you put parentheses around them. Group the last 2 terms, okay? Now guys, you're not asking any questions. Ask me questions. If you're not sure, ask me questions, okay? So in the first group, the first two terms, there's a GCF. There goes that GCF again. The GCF in the first two terms is 3x. When we factor it out, that leaves us with x minus 2. And guys, if you don't feel like asking the questions now, once I'm done recording, you guys can ask me all the questions you want. Personally, I would put a star next to the questions you might have or next to the problems you might have. So just write them down somewhere, okay? Now, for the second group, guys, that's just GCF of 4. When you factor it out, you're left with x minus 2. When you're factoring by grouping, guys, it's a must for these two parentheses, these two binomials right here, to be identical. If they're not identical, something is wrong, or the problem cannot be factored by grouping. So now you have the x minus 2 factor repeated, it becomes a GCF. So you want to factor it out. When you factor it out from here, that leaves you with 3x. That goes into the other parentheses. When you factor it out from here, that leaves you with plus 4 inside the other parentheses. So guys, there's your factored form, okay? I'm pausing here just in case you guys have a question. Okay, you guys don't look like you want to ask questions tonight, but that's okay. All right, you can save your questions for later. All right, guys. So I'm running out of room at the bottom, obviously. So I'm going to erase the top part of the problem so I can finish it out. Now, remember, take each factor, guys. You have the factors. So now take each factor, set it equal to 0, and then solve the problem. So I am going to go ahead and take that x minus 2, set it equal to 0, and solve. We can just eyeball this. What number minus 2 will make the equation equal out to 0? That would be 2. Now, the second one, you can't just eyeball it like that, guys, and come up with the answer. That's a little bit more challenging. So you want to subtract the 4 from both sides, leaving you with 3x equals to negative 4. And then you want to divide both sides by 3. So x is equal to a negative 4/3. So you got two solutions. The solutions are positive 2 or negative 4/3. And there you are, everybody. Okay, so that one was a little long. That's why, guys, you have all these different methods. So if you don't feel comfortable factoring to solve this problem right here, you could go to completing the square. You could go to the quadratic formula. You don't have to use this method, especially on a test when it's multiple choice. If they don't want you to show work, it's multiple choice. You can use whatever method you want to solve the problem, everybody. Okay? So now I'm going to move on to the second method, and the second method is the square root property. Now for the square root property, everybody, remember I told you it only solves some of the quadratics. When you're dealing with the square root property, first and foremost, check to see how your equation is written. What kind of form is it in? Is it in the form of x squared equals to some value, or can you get it to that form? Or perhaps, is it a binomial squared, like x plus a squared? Well, actually, you know what? Let me put a b in here. X plus b squared equals to c. Does it look like that? If your binomial looks like this one or this one, guys, those are the ideal candidates for the square root property. So here are some basic steps for the square root property. Number one, you want to isolate the square term. Isolate the square term. And what I mean by the square term, guys, is that x squared term. That's what I'm talking about. Get it by itself. Number two, you want to take the square root. Do the inverse of both sides. Take the square root of both sides. Now be careful here. When you take the square root of both sides, this is one of the ones that students often get tripped up on. Okay, when you take the square root of both sides, guys, the answer is going to be a compound solution, as in you're going to have two answers. So x will equal to a positive solution or a negative solution. I'll show you guys what I mean by that in a minute, okay? So be careful. Whenever you take the square root of both sides, you end up with a compound solution, a positive or a negative. And then step 3 is to go ahead and solve. All right. So square root property, very straightforward, guys. By the way, be careful because we're going to be taking the square root. Number 1, you're going to encounter negatives under the radical. So if you encounter a negative under the radical, here, let me put this on the side over here. If you encounter a negative under the radical, remember this becomes an imaginary unit. Furthermore, you will encounter radicals that need to be simplified. And if you find one, like we talked about oh no, we didn't talk about that one. If you need to simplify the square root of 18, guys, on my math lab in particular, they want this in simplified form. So 18, the square root of 18, to simplify it, you want to find the perfect square that goes into 18 evenly. That would be 9. 9 times 2 gives you 18. You want to go ahead and take the square root of 9. That comes out as 3, and then the 2 remains under the root. By the way, this is the one that is in that video that I'm going to send you guys on the imaginary solutions. I cover some of this in that video. So make sure you check out that video, okay? And go over some of the material in there. I'm just testing something out, guys. If it doesn't work, we can always revert back to what I typically do. All right, so now let me go ahead and go over some example problems, guys, so I can show you exactly what I'm talking about. Number 1, 2x squared minus 5 is equal to a negative 55. 2x squared minus 5 is equal to a negative 55. So here we are with a beautiful quadratic equation. So in order to solve this, we want to isolate the x squared term, get it by itself. So first, I am adding 5 to both sides. So I get 2x squared is equal to negative 50. Remember, I'm still isolating the x squared. I'm going to divide both sides by 2. So I get x squared is equal to negative 25. And then, once my x squared is isolated, I move on to step 2, take the square root of both sides. By taking the square root of both sides here, the square root will eliminate the power. Now, guys, remember, we just took a square root. Whenever you take a square root, you're going to end up to a compound solution. So the square root of negative 25 is an imaginary unit. So your answer would be plus or minus 5i. On my math lab, guys, on the tools palette, you do have the plus or minus tool on there. So you don't have to separate this. You can just type it in as plus or minus 5i. And that's it, guys. Okay, so let me go to number 2. And I still don't see any questions. I'm getting a little concerned about you guys. 3 times x plus 2 squared is equal to 21. That's example number 2. So for this one, the square term is x plus 2 squared. We want to isolate this. So we're going to divide both sides by 3, guys. And so the 3 cancels out on the left side, leaving you with x plus 2 squared is equal to 7. Now, again, you want to get rid of that power to solve for x. So you want to do the inverse and take the square root of both sides. So you get x plus 2. Remember, whenever you take that square root of both sides, guys, you do get a compound solution, plus or minus the square root of 7. We leave it like this because you cannot simplify the square root of 7. So you just leave it like that. But we're not quite done yet. We're solving for x. We're isolating x. So now, guys, you want to take that positive 2 and move it over. Subtract it from both sides. So you can solve for x. So you can get x by itself is equal to a negative 2 plus or minus radical 7. And guys, yes, you can input it into my math lab just like this, okay? Yes, my math lab will accept this solution. All right, everyone. I'm going to go to problem number 3. Problem number 3 is very similar to one of the questions you're going to see on the test. By the way, guys, in the last section, under the factoring section, problem number 3 in the last section, the one with the 3x squared, that one is going to be on the test. Does it matter the order? No, it doesn't matter the order. The only thing I caution you with is that when you're writing these solutions that have the radicals, if you have an imaginary unit, make sure the imaginary unit goes in front of the radical. And then the other thing I also want to say is this, guys. Eventually, we're going to end up into the quadratic formula. And the quadratic formula is in the form of negative b plus or minus, and then you have the square root. So we want to make sure we are mimicking that form. So when you write out your answer, make sure you have your real number plus or minus your irrational number. That's why we have it in this form right here, to mimic the quadratic form, okay? All right, everybody. So this next one right here, this is on the test, guys. This is gonna be on the test. Thank you for asking that question. Number 3, we've got 3x plus 2. Ooh, I've got my plus sign here. Plus 2 squared equals 9. Now we need to solve this one. Okay, so the square term is already isolated, guys. So then we're gonna move on and just take the square root of both sides. So the power cancels out the root on the left side, leaving us with 3x plus 2. Remember, when you take the square root of both sides, you end up with a compound solution, plus or minus 3. Now, what this is telling you is that you have 2 equations. For most students, okay, it's easier to break this up into the 2 separate equations, as in, oops, that's supposed to be a 3, guys. 3x plus 2 is equal to 3, or 3x plus 2 is equal to negative 3. That's what this means, guys. You have 2 equations there. Now, for some of you, you will probably be okay with working this out right here, working it out as a compound equation. And there's nothing wrong with that. You will end up with the same answer as well, okay? The only thing is, make sure when you end up with your answer, you give 2 exact solutions, because this one is going to end up with 2 exact solutions. So now I'm solving each equation. I'm subtracting 2 from both sides, so I get 3x is equal to 1, and I divide by 3. So one of my solutions is x is equal to 1/3. I'm going to go to the other equation, subtract 2 from both sides. So I get 3x is equal to a negative 5. And I'm going to divide both sides by 3. So x is equal to negative 5/3. And there we go, guys. 2 solutions. 1/3, negative 5/3. Any questions? All right, everybody. Now, if you don't have any questions about this, what I'm going to do is move on to the next method, which is going to be about completing the square, guys. No questions? Okay. Remember, I will be opening up the floor for questions after I'm done with the recording, guys. So part 3, everybody, is on completing the square. This is another method we use to solve quadratic equations, and it does solve every single quadratic equation, completing the square. Now, for completing the square, I like to tell my students this. It works for all quadratics, but it works best. And what I mean by that, it's an easy method to use if you have these type of equation. If A is equal to 1 and B is even. And what I mean by this, guys, is that you will not end up with any fractions. If you are doing completing the square on these type of equations where A is 1, the leading coefficient is 1, and then of course your B is even, you avoid the fractions. It's the fractions that terrify students. So if you can find a way not to deal with them, that's the ideal way to go. Okay, guys, so in order to explain this, I am going to start with an example. And then as I go through the steps, I will show you how the steps work within the example. Okay, so step number 1 is to move C to the right. Move C to the right, guys. Move C to the right. Which one is the C value? The -5. So we're going to take it and move it over to the right side. Notice I'm leaving a little bit of space here after the 6x. That's for when we do complete the square. Now, this next step right here becomes a moot point within the context of this problem, but I have to include it. And that is to divide both sides by the leading coefficient, by A. Unfortunately, the A value here is 1. So if you were to divide both sides by 1, you would still have the same equation. So this is why it's a moot point. But step number 3, guys, this is the critical step right here. We're going to complete the square. Okay, this is where we complete the square. Now, when it comes to completing the square, guys, very critical step right here. Let me use a different color. You do half of B, square it, and then you want to add it to both sides. Add to both sides. That's critical right there, guys. Okay? Take half of B, square it, add it to both sides. So I'm going to do this very slowly so you guys can see what I'm talking about. The B value is 6. So I'm going to take half of 6. That's going to give me 3. Then I'm going to square it, raise it to the second power. That's going to give me 9. So now I'm going to take the 9 and add it to both sides. I'm adding the 9 to both sides. That's how you're going to complete the square. So if you add 5 and 9 together, you get 14. And then this will equal to x squared plus 6x plus 9. Now that x squared plus 6x plus 9, you're going to factor it, okay? Factor the left side. Factor the left side. Factor left. Now, I'm going to go through this the long way, but eventually I'll show you the shortcut. So we're factoring the left side, guys. What two numbers multiply to give us 9 and add to give us 6? That'll be x plus 3 and x plus 3. 3 times 3 is 9. 3 plus 3 is 6. What you will notice is that these two binomials, they're identical. So we're going to rewrite this as a binomial squared equals to 14. And then the last step is to use the square root property to solve this. Use the square root property to solve. So you're practically done, guys. So now you take the square root of both sides and you get x plus 3. Don't forget that plus or minus. The square root of 14. And then you want to go ahead and move the 3 over to the right. And when you move it over to the right, you're left with -3 plus or minus the square root of 14. And there you are, guys. All right, now on the test, I know there's one question that says to use completing the square. However, if you don't feel comfortable with using completing the square, you don't have to, especially since the test is going to be multiple choice. It's the same thing with My Math Lab, guys. Even if the problem says complete the square, you don't have to. If you feel comfortable with a different method, use the other method to solve the quadratic equation. The goal is to solve it. How you solve it really doesn't matter. It will produce the exact same answer. Of course, there are certain quadratics which you cannot factor, so you can't use the factoring method if it's not factorable, okay? So guys, I'm going to do one more like this, and I will move on to the quadratic formula, everybody's favorite. So here's the second one, second example, and it is x squared minus 4x minus 5 is equal to 0. Now, on this one right here, I've got, let me see here, minus 4x minus 5. I'm going to use completing the square. But guys, once we're done with this, I'm going to show you something else. So I move my 5 over, which becomes a positive 5. Then I'm going to take half of b. b is -4. You don't even need to worry about the sign, but just for purpose, I'm just going to go ahead and put that negative in there. So I'm going to square the -2. That's going to give me a positive 4. So now I'm going to add the positive 4 to both sides. So now, guys, 5 plus 4 gives me 9. Now, I told you I was going to show you a shortcut. Here's the shortcut. Set up your binomial squared because this is a perfect square trinomial. Every time you factor it, it's going to become a binomial squared. How do you get it? You take an x from the x squared, okay? Bring that minus down and take half of 4, that gives you 2. So there's your binomial squared. So I take an x from the x squared, half of -4 gives me my -2. And so once you do this, guys, look at this. You're almost done with the problem. Take the square root of both sides. You get x minus 2 is equal to plus or minus 3. And then to finish the problem out, we're going to add the 2 to both sides. That's the same thing as taking the -2 and moving it over. So I get x is equal to 2 plus or minus 3. Guys, remember, this reflects two solutions here. 2 plus 3, which is 5. 2 minus 3, which is -1. And there you are.
I have a question.
Yes.
From you were at x squared minus 4, x plus 4. So you square rooted the x squared, but how did you get -2?
Okay, I didn't square root the x squared. I was factoring over here, actually. I factored over here. I just did a shortcut. So, you know, with the last problem, I worked it out so you could see where it's coming from. Yeah. I'm factoring the x squared into x times x. And then I'm looking for two numbers that multiply to give me a +4 and add to give me -4. That would be -2 and -2. But this is a repeated factor. So I rewrite it as x minus 2 squared.
Okay. All right. Thank you.
No problem. All right, everybody. That is completing the square. I'm not going to do another one using completing the square because the other examples I have, they lead into a whole bunch of fractions, and I don't want to bombard you with the fractions. So I'm going to go straight into the quadratic formula because this is everybody's favorite anyways. So quadratic formula is next, guys. And this is method 4. By the way, I had also mentioned graphing. So under the quadratic formula, I am going to mention graphing as well. The quadratic formula, again, this is everybody's favorite because it will solve every single quadratic equation. So if you cannot factor, use the quadratic formula. If you cannot do the square root property, use the quadratic formula. If you can't complete the square, use the quadratic formula, guys. And the reason why students prefer this method is because it is a formula. You're just plugging in the values and simplifying. That's the other thing I have to remind you to do. Make sure you're simplifying, guys, okay? So here we go. Now, you don't just go straight into the quadratic formula. There are steps to this, guys. So step number 1, you have to isolate the quadratic. Set the quadratic equal to 0. And then number 2, you have to list the value or values of A, B, and C. Okay, A, B, and C. Remember, when you're looking at a quadratic equation, it looks like this. So A is the number in front of x squared. There's your A value. Your B value is the number in front of x. And then your C value, guys, is the constant term. Now, if B or C is missing, fill in 0. Fill in 0, guys. If your B or C is missing, fill in 0 for either B or C. Remember earlier I told you, you can't have the quadratic term missing, okay? So guys, once you have this taken care of, the next step is to go ahead and substitute A, B, and C into the quadratic formula. And I'm going to have to erase all of this so I can show you the quadratic formula. And of course, you know what? Let me go ahead and stick number 4 right here. Simplify, that's the last step. I'll show you the quadratic formula in a minute. So guys, as you do this, please be careful with the signs. That's number one. Number two is to make sure you are simplifying, reducing, simplifying as you go along. Because in my math lab, if you provide the answer and it's not in reduced form and simplified form, the computer will mark it wrong. All right, guys. So here's your quadratic formula. It's x equals to the opposite of b. I like saying the opposite of b. You could also say the negative b, plus or minus. And the reason why I say opposite of b is to remind me to change the sign of the b value. Plus or minus the square root of b squared minus 4 times a times c. And then everything, all of it gets divided by 2 times a. That's the quadratic formula, guys. Now, I need you guys to pay a particular attention to this part right here, and that is the discriminant. The discriminant is the part inside the square root, underneath the square root, guys. B squared minus 4a times 4 times a times c. Basically, the discriminant tells you the number and types of roots. How many roots and what types of roots the quadratic will produce. Remember earlier I told you the maximum number of solutions you can find for a quadratic would be 2 solutions. So here we are actually differentiating the solutions and identifying how we come up with the different types of solutions. So guys, here it is. If you calculate the discriminant and it's greater than 0, as in it's a positive number, then this is going to lead to 2 real roots, as in 2 real solutions, 2 real answers. So if you work out the quadratic and you get the discriminant, you get a positive value, 2 real roots. However, if you work it out, guys, you get exactly 0. This will produce 1 real root because the square root part of it will simplify out. And then the third case for the solutions is this. If you work out the discriminant, you get a value that is less than 0, as in it's a negative value. This will produce 2 imaginary or complex roots to the quadratic equation. 2 imaginary or complex roots, guys. So pretty much there's 3 types of solutions to these quadratics, guys. 2 real roots, 1 real root, or the third case is where you have 2 imaginary or 2 complex roots. All right, everybody. I think there's a discriminant question on the test, so make sure you know how to do discriminant, okay? Next, the graphing part of this. Like I said, I was going to mention the graphing, okay? For the graphing portion of this, guys, I am just going to show you what the solutions look like on a graph. So if a quadratic were to have 2 real roots, when you graph this quadratic, guys, the graph will look something like this, where the graph is intersecting the x-axis twice, and wherever it intersects the x-axis, this would represent a solution. So this would be your 2 solutions, okay? Here's the second case. The second case is when it has 1 real root. If it's got 1 real root, when you graph this quadratic, the quadratic will intersect the x-axis just once. So you might have something like this. And that 1 point of intersection, by the way, that's a touching. That 1 point where the graph is touching the x-axis would represent the 1 solution. And then the third case, okay? The third case is where you have 2 imaginary or complex roots. And when you have imaginary roots or complex roots, guys, this means that you cannot see them on the graph. You cannot identify them on the graph. So when this happens, hold on a second, let me try this a different way. Hold on a second. So when this happens, if you're looking at a graph, the graph will never intersect the x-axis. So you might see something like this, where the graph will not intersect the x-axis because there's no real solutions. So these are the three cases for graphing the quadratics, using graphing to solve the quadratics. So guys, what I would like to do now is to run through some example problems. In particular, we had that one question at the beginning of class with the factoring method. And I told you guys, you know, when it gets this hard, this is where you have to consider other methods to solve the quadratics. So that's the first one I'm going to look at with you. So here's the first example, guys. It was 3x squared minus 2x is equal to 8. Now, for this particular problem right here, the first step is to take that 8, move it over. Okay, take the 8, move it over. So it's going to become 3x squared minus 2x minus 8 equals to 0. So now once you have your quadratic equal to 0, find your a value, your b value, and your c value. Be careful with the signs, guys. A is 3, b is negative 2, and c is negative 8. So now we're going to go into the formula. And let me use a different color. We're going to go into the formula and we're going to substitute everything into the formula. I like writing the formula down. By writing it down over and over again, it helps you to memorize the formula, guys, okay? So now let's go ahead and substitute those values in there. So x is equal to the opposite of b. Notice b is negative, so it's going to become positive. Plus or minus the square root of. Be careful, guys, with the signs. Notice how I'm enclosing the negative 2 inside a set of parentheses and squaring it. Minus 4 times a. A is 3. C is negative 8. And all of this gets divided by 2 times a, which is 3. So now, guys, it's all about simplifying the problem. So you grab your calculators. And then you want to enclose, put all of this into the calculator. Don't put the square root, just put all of this into the calculator. Negative 2 squared minus 4 times 3 times negative 8, and then you work it out, guys. Now, I'm going to go over here to the side because I'm running out of room at the bottom. So here, guys, if you do the discriminant turns out to be 49. Make sure you guys are checking it to see if it's actually 49. 4 times 3 is 12. 12 times 8. Oh, no, that's wrong. That's supposed to be, Shazam, 100. Fix that for me, please. That's 100, guys. I'm fixing it. All right. So that's 100 right there. Okay. So do it on your calculator. See if you're getting that 100. If you're not getting that 100, something's wrong. And all of this is divided by 6 because 2 times 3 is 6. Any questions, guys? You guys are very quiet tonight. You're not asking any questions. I guess you're saving all of them until the end. Oh, Maddie, I can see why you got the 92. The reason why you got the 92 is because you didn't square the negative 2. You have to enclose it inside a set of parentheses. And Maddie, the other thing is this, whether the number is negative or positive, when you square it, it's going to turn out to be a positive anyways, okay? So I would just go ahead and do 2 squared instead of negative 2 squared. Do 2 squared and then minus 4 times 3 times negative 8 and see if you get that number.
Okay, thank you.
All right, guys. So now we take the square root of 100. The square root of 100.
Yes, I got 100 now.
Okay, good. All right, so guys, what I want you to notice is that you now have a compound solution, which requires you to simplify it. So we're going to simplify it. One of the solutions is going to be the sum, 2 plus 10 divided by 6. So that's going to give you 12 over 6, which is 2. Now, you're going to have the difference for the other solution. 2 minus 10 over 6, which gives you a negative 8. And negative 8 over 6. Notice we have to simplify this one, guys. Simplifies to negative 4/3. Remember, this is the problem from earlier And as you can tell, guys, what happened? We ended up with the same answer, even though we use a different method. We got the exact same answer. And I'm sure some of you are feeling way more comfortable with this method instead of factoring. Any questions, guys?
So the answers would be x equals 2 and x equals -4/3.
Yes, yes, yes. Let me go ahead and circle those for you. All right, right here. And here's the other one. It's kind of like squeezed at the bottom. There you go. Okay, yep. All right, guys. Should I do another one, or are you feeling a little bit more comfortable with this one and I don't need to do another one? What do you want to do?
Another one, please. Elisa.
Another one.
Yeah, another one.
Okay. So let me see here. Hold on, guys. I got to find another one for you. And then, let me see. Okay, I don't have a good one per se, but I'm just going to go ahead and do this one right here. Now, this next one right here, guys, very similar to the one we just did. It is going to come out to be two exact values. This is example number 2. 2x squared plus 5x is equal to 3. How about you guys give it a try first? Give it a try. Let's see how well you do with this one. And in the meantime, I am going to search for another problem for you, something that's a little bit more challenging. Oh, okay. We can do this one right here. No, that's not a good one either. Once we get the answer, let me see here. Should we hold on to it? You can share it out, Melanie.
Almost done.
Okay. Absolutely. Let me see, where am I on time? Has it been an hour? I wanted to look at some of the word problems with you guys too, because I haven't done any of the word problems with you. And some of them are a bit challenging. All right, 1/2 -3. Oh, that's looking really good, Melanie. All right, so let's check it out. So move this 3 over, guys. I'm not sure if that's right, though. Have confidence in your answer, Melanie. Okay, so I'm moving the 3 over, guys. So when I move it over, I end up with 2x squared plus 5x minus 3. We're going to list the values of a, b, and c. So a is 2, b is 5, c is -3. And we go into the formula x equals the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, divided by 2 times a. So when I plug this in, I'm going to use a different color here. The opposite of b will be a -5, plus or minus, check your work, guys. 5 squared minus 4 times 2 times -3. Okay, and all of this gets divided by 2 times 2. So when you work out what's inside the square root, guys, inside the square root, it's going to simplify to 49. And this will be divided by 4. The square root of 49 is 7. Ooh, why am I keeping the square root again? That's wrong, okay? So 7, and all of that goes over 4. So now, guys, essentially you have two answers here. This is the compound solution. So one of them will be -5 plus 7 divided by 4, which is basically going to give you -1/2. So there you are, Melanie. And then the second one is going to be -5 minus 7 over 4, which gives you a -12 over 4. So the answer turns out to be a -3. So you see, you guys were right, okay? Maddie, you were right. Melanie, you were right.
Negative with the half.
You swapped the negatives. Okay.
I accidentally forgot to
Oh,
bring.
wait a minute. Hold up a second. That's my mistake, actually. It is a +1/2.
Oh, it is?
I put a negative in there, Shazam. I didn't even realize I put that negative in there. So yeah, that's my error. You see that?
Okay, yeah, so I did, okay.
Yeah, so the solutions are 1/2, -3. All right, there we go. So you were absolutely right.
Thank you.
Uh-huh.
A little bit, but.
All right, guys. So I can do one more if you guys want to. We won't have to.
I'm good with it.
You good with one more? Okay, so this one is going to be a little bit more challenging because it's not going to come out to be exact values. So guys, here's the third example. 3x squared plus 4x minus 2 equals to 0. You guys feel like you need me to go over some of the word problems? The word problems are in lesson 1.3. The application section. Yes, please. Okay. All right, so I will do maybe 2 or 3 of the word problems, and then I will turn off the video. All right, guys, so on this one right here, it's already equal to 0. So we identify A, B, and C. So there's our values. Now we go into the formula. I'm not going to write the formula down. I'm just going to go straight into it, guys. The opposite of B would be -4 plus or minus the square root of B squared minus 4 times A times C. And all of this gets divided by 2 times A. Now, we want to simplify what's inside the radical. 4 squared is 16. And then 4 times 3 is 12. 12 times 2 is 24. So this is going to be 16 plus 24. Now, 16 plus 24, guys, is going to be 40. So as you can tell, this is not going to turn out to be an exact value. So you're going to have to simplify here. Okay, so let's talk about simplifying radical 40. Radical 40 has a perfect square that goes into it evenly. That would be 4. 4 times 10 is square root of 40. Now, the reason why I break it up into 4 and 10 is because you can take the square root of 4. The whole purpose of simplifying these radicals is to find a perfect square that goes into it evenly. So now, guys, I am going to go ahead and take the square root of 4, which comes out to be 2 on the outside. And then the 2 will remain inside the root. Okay, can you guys see the bottom? Are you guys blocked? Are you guys seeing the bottom?
You see the denominator 6. Is there anything?
So you can't see it?
No.
Okay, let me see. How can I remove it? I'm not sure how to remove this. Okay, I cannot remove this bottom window here. Okay. I can't get it to go away, guys. But anyways, I'll move to the side, okay? So this is where we're at. X is equal to -4 plus or minus 2 radical 10 over 6. Now, guys, this is what I mean by you must simplify these. If you were to type in this answer exactly like you see it right now into my math lab, the problem would be wrong. And so what you need to notice is that -4, the 2, the 6, they're all even and they're all divisible by 2. So I'm going to divide the 4 by 2. So that's going to leave me with 2. Divide the 2 by 2. That's going to leave me with 1. And if I simplify the 6 by dividing it by 2, that leaves me with 3. So pretty much this problem simplifies to -2 plus or minus the square root of 10 over 3. Now, if you don't like the answer this way, guys, the other option is to separate this into two fractions, very similar to what I did. Oh, I just realized I didn't cover that with you guys yet. Okay. In the complex numbers, when you're writing them out, you need to write them out as two separate fractions, as in A plus BI form, the same thing here. So if you wanted to break this up, you could break it up into -2/3 plus or minus the square root of 10 over 3. Either one of these guys is correct. Either one is correct. But on a test or an assignment, you could see either forms. All right, guys. So now let me take a few word problems and then I will stop the recording. I am going to go into the assignment so I can grab the word problems. Unless somebody has their word problems all pulled up, the assignment pulled up with the word problems, preferably the homework for lesson 1.3. If you have it pulled up, you can share your problems. You can even share your screen with us, and I will help you to do your problem while everybody else pays attention. Anybody have their problems pulled up? Okay,
No.
that sounds like a no. So I am going to pull up my screen here. Let me go ahead and go into the assignment. Guys, this is going to be homework number 3. And I am going to go and grab some word problems from there. Hold on a second. Access denied, Shazam. Okay, let's try this one more time. Let me refresh the page here.
With the last problem that you just did,
Uh-huh.
we didn't finish it, right? Or was that the final answer?
Oh, that is the final answer. Yes.
Okay.
Uh-huh. You can't do anything else with it, so you have to leave it like that.
Okay. And I don't know if you forgot or not, but the attendance.
Yes. Let me go ahead and give you the code for the attendance. Hold on a second. Let me get these word problems situated. See, now one of my other classes. Oh, wow. Okay. All right, guys. Let me see if I could share the screen with you. I am in homework number 3, lesson 1.3, 1.4. Let me go into Zoom and see if I could share this with you so you can actually see it. All right, everybody. So this is problem number 2. It says after a 75% reduction, you purchase a new clothes dryer on sale for $145. What was the original price of the clothes dryer? So what I tell students is this: when you're working through these type of word problems, the first question you have to ask yourself is the price going to be greater than or less than the 145? That's the first question you should ask yourself. Is the price going to be greater than or is it going to be less than the 145? What do you guys think?
It'll be greater.
greater than, okay? So pretty much, if you're looking at a word problem and you've already surmised the answer is going to be greater than, that will help you to filter out some of the answers, you know, eliminate some of the answer choices. Let me see, where's the attendance code? Hold up a second, guys. I wrote it here somewhere. All right, everybody, it's 8632. I'm putting it in the chat. 8632 is the attendance code. All right, so on this one right here, guys, I'm just gonna go ahead and annotate right here on the screen so I don't have to go ahead and put up my board again. Okay, there we go. So guys, listen, after a 75% reduction, you're purchasing this clothes dryer for $145. So the question is, what was the original price? So on this one, guys, what you have to think about is the original price is 100%. Okay, this is one way of approaching the problem. The original price is 100%. It's hard to type on here, guys. I mean, right on here, okay? You're going to reduce the price by 75%, okay? By the way, that's a 7 right there, guys. Okay, I'm writing on the computer screen, so this is not as great. So guys, if we were to take away 75% of the original price, this would drop it down to 25%. So in other words, we are going to pay 25% of the original price. Here, let me write this down for you. 25% of the original price, which we don't know. So that's why we're going to reference it as some X value. And this will equal out to the 145. Now, of course, when you're dealing with percentages, you want to change the percents to a decimal. So 25% as a decimal, guys, is 0.25. Okay. And then times X equals to 145. Now, there's your beautiful little equation. And then to solve it, you want to grab the calculator and take 145 and divide it by 0.25. So you're just dividing 0.25, both sides by 0.25. So 145 divided by 0.25 will give you 580. So the answer is $580. Now guys, you can check this too. Yeah, if you were to do 25% of 580, is it gonna give you 145? Okay, so there's the answer for that one. Any questions?
How would you double check your work?
All right, very good. Okay, to double check the work, you have a couple of options, but I think the easiest option is to actually figure out 25% of 580. So if you take 580, you multiply it by 25% or 0.25, is it going to give you that 145? Because if you're getting a reduction of 75%, obviously you're only going to pay 25% of the original price. And if you multiply 580 times 0.25, yes, it will definitely give you the 145.
Okay, thank you very much.
Mm-hmm. All righty, guys. Let me see here. Let's take a couple more, and then I will go ahead and turn off the video. Okay, look at this one right here. Do you guys want me to do it?
Sure.
Yes, please.
Uh-huh. All right, guys. So on this one right here, we've got including an 8% sales tax on end charges, $137.16 per night. Find the end's nightly costs. Once again, guys, ask the question, is the answer I'm looking for going to be greater than or is it going to be less than the 137.16? In other words, does sales tax increase the price of an item, or does it decrease the price of an item? That's how you approach it. So is the answer, guys, going to be greater than or less than the 137?
Greater.
It would be less than.
Less than, yes, less
Oh.
than. All right, so just be careful with that. Remember, sales tax increases the price of an item. So if their sales tax is included in the 137, that means that the price before the tax is added would have been less than the 137. So yes, it's going to be less than. So guys, again, here's one way to approach this problem, and I'll show you another way to approach the problem as well. And your choice. I mean, it really doesn't matter to me how you do it. Okay, it's your choice. Okay. So guys, 8% sales tax. So pretty much you have the price of the item. Once again, I'm going to go back to that 100%. That's the original price of the item. Then you're going to add, ooh, I'm doing a terrible job with this. You're going to add the sales tax of 8% to increase the price of the item. So in the end, you're going to pay 108% of some number to get to 137.16. Now, I like doing it this way because that 100% makes sense to a lot of students. I'll show you the other way that you guys are typically doing these type of problems in a minute. But guys, listen, 100% plus 8%. This includes the price and the sales tax. So that gives you 108%. Remember, you always change your percents to a decimal. So 108% as a decimal becomes 1 point. Okay, you know what? I'm just gonna go straight to it, guys, because I don't want to keep writing with this thing. It's annoying. Okay, 1.08. That's 108, 108% as a decimal, and then times the x, and then all of this will equal out to 137.16. So just like with the previous problem, guys, to finalize it, you want to go ahead and divide both sides by 1.08. 1.08 to get to your answer. All right. So go ahead and do your division, guys. Let me go ahead and do it. 137.16 divided by 1.08 comes out to 127. So there's your price. Before tax is added, it's $127 a night. Think about it. If you were to go to this hotel and they tell you the price was $137.16, including tax, what did you pay? What was the hotel's rate before taxes was added? Yeah. All right, guys. Now, on a side note, okay, I just want to mention this. Normally, when you guys do, oh, you know what? Let me just erase this because this is getting a bit too messy for me. So let's quickly erase this part right here. And I'll show you the other way that most of you are used to doing these problems. And it works. The only issue is that some students tend to get confused with the variables there. So let me go ahead and show you guys for those of you who are comfortable with it. Okay, so here it is. Wait a minute. All right, guys. So typically you're used to doing this. X is the original price plus the sales tax. What's the sales tax? 0.08x. So the price plus the sales tax is equal to the 137.16. Now, guys, if you were to add x plus 0.08x, this is where the students get confused, you get 1.08x, right back to where I was when I showed it to you using the 100%. The issue is this: students don't know where that 1 comes from. Why is that 1 there? That's the issue, guys. But you notice it's the exact same problem, okay? That's how you guys are used to doing it. But the 100% makes sense. It makes more sense to you guys. I don't know why, but it makes more sense, okay? So next problem, guys. Like I said, I was gonna do 2. I mean, total of 3, but one more. So guys, here comes the next one. I'm going to do the interest question. The interest question is definitely on the test, this one right here. I'm going to work it out on my board. Now, you guys can take a moment and go ahead and read it. And I will go ahead and share my board with you so we can work it out together. This is on the test. And then one of the percent questions will also be on the test. I don't know exactly which one. But this interest rate one, guys, is always on the test. So on this one right here, guys, you have invested 23,000. Oh, can I annotate on here? Let me see if I can write on here. Hold on a second. Maybe I could. Nope, I can't. Shazam. Okay. No, it won't allow me to do that. Okay, guys. So on this one, 23,000 invested in 2 accounts, paying 7% and 8% annual interest rate, respectively. If the total interest earned for the year was $1,710, how much was invested at each rate? All right. So I'm going to stop sharing here. I am going to go to my iPad and share. Okay. Now, again, guys, the beautiful thing about this is that it's being recorded. So if you don't understand what's going on, just go ahead and go back into the video and pick up from this section right here, and you'll be okay. All right, everybody. So you guys might have to remind me, what did the problem say again? 23,000, 7% and 8%. And how much interest was earned for the year? 1,700?
1,710.
Very good, thank you. Okay, so the total interest earned for the year was 1,710. So essentially you have 2 accounts, okay? And you're investing a total of 23,000 in the 2 accounts, guys. So the question is this: how much was invested at each rate? Now, there's 2 ways to do this problem. You can do it in 1 variable or you can do it in 2 variables. So I'm going to show you the easier of the 2. And then if you want me to do it the other way, I can also do that for you. So the easiest way to do it, guys, is the 2 variables. So we're going to call the first account, the amount we invest in the first account, account number 1, X. We don't know how much we're investing in there. We'll call it X. The amount invested in account number 2, we'll call it Y. And then added together, the total amounts from these 2 accounts added together accumulates to 23,000. That's how much you have in these 2 investments. Now, for the interest, to calculate the interest you earn in an account, you want to take the interest rate and multiply it by how much money was invested. So for the first account, it was invested at 7%. 7% as a decimal, guys, is 0.7, and you multiply it by the amount invested. That will give you how much interest you've earned on the first account. Now, for the second account, again, you take the interest rate, which is 8%. As a decimal, it's 0.08. You multiply it by how much was invested to calculate the total interest you've earned from the second account. If you add the interest from the 2 accounts, the total interest from the 2 accounts adds up to $1,710. All right, so now we're going to solve this problem. To solve this problem, I am going to use what is called the substitution method, guys, okay? So if I'm using the substitution method, I have to take one equation and substitute it into the other. In order for me to do that, I have to solve for one of the variables. So I'm going to go to the first equation. I'm going to solve for for y, guys. I'm going to move x over to the right. So the first equation will become 23,000 minus x. Now I'm going to go to the second equation, and I am going to substitute, guys. Substitute the 23,000, oops, that's 23,000 minus x into the second equation for y. So there's my beautiful equation. Yeah, let me fix this over here. That looks a little fuzzy. All right. Any questions, guys? Anything? Okay, this is one way to approach this problem. I can show
When
you
you
the other way as well. Go ahead.
when you said wait, so I'm kind of lost. You said multiply the amount you invested
Mm-hmm.
by the percent, right?
Mm-hmm.
I don't I don't know what I'm doing wrong then because I didn't get the same thing. Um, mm,
What, okay, what do you have written down for that part?
oh, well, I looked at mine. My numbers are different than yours,
Right.
but it's the same
Absolutely.
problem.
Uh-huh.
Okay. So I have 17,000
Uh-huh.
was invested into both accounts.
Uh-huh.
One 8%, one 9%,
Uh-huh.
and the total interest you earned was 1,470.
Right.
And so you said I would multiply 17,000 times 0.08, right?
No, no, you don't know how much was invested in each account. So if you're going to multiply 17,000 times 0.08%, you're saying you invested 17,000 into the first account, but the
Um,
17,000 is for both accounts. And the problem here is asking you to find how much was invested in each account because you don't know how much was invested in each account. That's your job, to find how much was invested in each account.
oh, okay.
All
Wait.
right.
So then what would I do then?
Okay. So this is one way of doing the problem. Since you don't know how much was invested, okay, we use variables to represent the amount invested in the two accounts. So in one account, I would invest X amount, and the other account, I would invest Y amount. And if I add the two amounts together, that gives me the total of my investments, which is the 23,000. So that's my first equation. Now, for the second equation, I'm going to call this my interest equation because I know the total interest I've earned from the two accounts, but I still don't know how much was invested in each account. So for me to figure out how much interest I earn off each account, I'm going to take the interest rate multiplied by how much was invested. Now notice it's X because I don't know how much was invested in the account. That's the first one. For the second one, I am taking the interest rate on the second account and I'm multiplying it by how much was invested. I don't know how much was invested. That's why I'm calling it Y. And when I add these two values together, that's going to give me a total interest earned from the two accounts of that 1,710. So essentially, the format I'm giving you, this template, you can follow through with this template to solve your problem. The only difference is that your numbers, obviously, they're going to be different. That's it. Okay. And we will get to those values, but right now we have no idea how much was invested in the first account, how much was invested in the second account. And that's our job, to figure out the amount invested in each account. Okay. So guys, let's finish it out so we can figure out the amount invested in these accounts. So I am going to take this 0.08 and I'm going to distribute it. So if I take 0.08 and I multiply it by the 23,000, it's going to give me 1840. And then the 0.08 times negative x gives me negative 0.08x. We're coming up to the answer. And then once we're done with it, guys, we can check it. So now we're going to combine like terms. Combine these two together. So we get negative 0.01x. And then bring down that 1840 and set it equal to 1710. I am going to subtract the 1840 from both sides. So when I subtract the 1840 from both sides, I'm left with negative 0.01x is equal to 1710 minus the 1840. Okay, why am I doing this on a calculator? Negative 130. Okay, so guys, the last step, is to go ahead and divide both sides by 0.01 to get your answer. And this turns out to be 13,000. Okay, so now what is this telling us? 13,000 is the amount that was invested at what percent, guys? 13,000 is the amount invested at what percent?
0.7.
0.7 or 7%. Excellent. So we had a total of 23,000. We invested 13,000 at 7%. So how much is left over to invest at the 8%? So we invested 13,000 at 7%.
Is it 10,000?
Right, 10,000 would be invested at 8%. All right, I can hear you guys' thoughts right now. Wait a minute, wait a minute. Why are we investing less money at the higher interest rate? Yeah, okay. I can hear you guys. That happens. It happens. All right, so now guys, let's check this. Does it actually work out? Let's check it. By the way, the checking is also a great test-taking technique because you can use that, guys, to get through the problem without having to do all this work right here. So how do we check it? We grab our calculator, we do 8% of 10,000. What's 8% of 10,000? Let me see here. Let me grab a different color. 8% of 10,000, that's 800. Okay? And then you're going to do 7% of 13,000. Now, 13,000 times 7%, what does it come out to? 910. So if you were to take the 910 and add it to the 800, guess what it would add up to, guys? 1710. That's how you check your problem. And guys, you can do this on the test. If you're not sure how to do the problem, take the answer choices and guess and check them. Multiply the 10,000 times 8%, gives you 800. Multiply the 13,000 times 7%, gives you 910. When you add them together, if it gives you the total interest earned, that's the correct answer. All right, guys. So there is another way to do this problem. How are you guys feeling about looking at it? Do you just want to leave it this way? Do you guys want me to do it the other way? No? What's the attendance? Oh, it's in the chat. I don't remember exactly what it is. Okay, sounds like you guys don't want me to do it the other way. 8632. Okay, somebody was gonna say something. Go ahead.
I was just asking if the other way is harder.
It depends, man.
That answers my question. Nope, never mind. Nope.
We'll leave it this way.
Okay, everybody. So I'm gonna stop the recording and then I'll go ahead and take your questions, okay?